Hello students, how are you all? Welcome to AP Calculus. So in this video we are going to cover one of the important tests which is called Divergence Test, and this is also known as the Nth Term Test. By using this test we will learn whether a particular infinite series converges or diverges. So first of all, let us see what is this test about. This divergence test, as we have discussed, this is also known as the Nth Term Test for divergence. It is used to determine if an infinite series diverges. So a series will be given to us just like this. Let's say n goes from 1 to infinity, sigma an. A series will be given to us. So what we have to do when this particular type of series is given, we just have to take the term for that series. Like in this series, apart from the sigma, whatever is this term, we will be taking this particular term and we will apply this condition. It means limit n tends to infinity for an. Now if this is not equal to 0, whatever answer is there, if it is not equal to 0 or if the limit does not exist, like it could be infinity, it does not exist, it should not be equal to 0. If it is not equal to 0, then we will simply say series diverges. Only one condition is that if the limit is not equal to 0, and apart from 0 it could be infinity, it could be does not exist, we will simply say the series diverges. But an important thing is, if this limit comes out to be 0, then this test is inconclusive, means the series may converge or may diverge. We cannot comment upon that, and in that case we need some another test to check if the result comes out to be 0. Let's take two examples for this. So as we have discussed the P series earlier, these are the two examples of the P series. If you solve it by the divergence test, like here, what is this an? This is your an. So if we calculate limit n tends to infinity for this an, 1 by n square, you know that when n is going toward infinity, 1 upon infinity square, that will be 1 upon a very large number, that will become 0, right? And in the second case also, here if you check limit n tends to infinity 1 upon n, this is also coming out to be 0, so both of them are 0, but one of the series converges and one of the series diverges. So I am using the concept of P series test. According to the P series test, here the value of P is this 2. So P is equal to 2 over here. So since P is greater than 1, therefore this series converges. If the exponent of the n is greater than 1, this series converges. And here, what is the value of P? You can see in the next page, you can say here what is the value of the P? P is equal to 1. Since P is less than or equal to 1, we say the particular series diverges. According to the P series, this is the standard one, 1 upon n power P, n goes from 1 to infinity. If the series is written in this format, then two conditions are there. If P is less than 1, one second, here if P is greater than 1, we say the series converges. If P is less than or equal to 1, the series diverges. So you can see in both of them the limit is going towards 0, but in one case the series converges and in the second case the series diverges. So we cannot comment upon this. It can be converging, it could be diverging. Okay, so let's see what is the summary for this test. Three important points. First point is, we will only see if the limit is not equal to 0, then we will simply say the series diverges. The case is inconclusive if we are getting a limit equal to 0, because if the limit is equal to 0, we will say simply the test fails. Just like the two examples we have discussed, this it could be converging or it could be diverging. Similarly, no convergence proof. The test cannot be used to prove that a series converges. We only use this test to say the series diverges. We cannot comment upon this whether it will be converging or not. It is only used to prove the divergence. So let us take some of the different examples. The first thing, it is written, use the divergence test to determine whether the series converges or diverges. So this is the term given to us. So we will simply find the limit n tends to infinity, whatever is this term given, this term. So n over n plus 2. So we have solved this many times. It is polynomial divided by polynomial. Degree of polynomial is same, 1 1. So ratio of leading coefficient is the answer. Leading coefficient in the numerator is what? 1. Leading coefficient in the denominator is what? 1. So answer is 1 upon 1, which is 1. Now since it is not equal to 0, so we simply say it diverges. Simple as that. Let's take another example. Here again it says use the divergence test to determine whether it converges or diverges. So again we will say limit n tends to infinity for this n upon 5n square minus 3. Now in this case you can see the degree of numerator is less than the degree of denominator. Whenever this happens, when the degree of numerator is less than the degree of denominator, the answer for this is always 0. So since it is 0, what happens is if the limit comes out to be 0, therefore we say test is inconclusive. We cannot comment whether this particular series converges or diverges. Now we have to use any other test. Now I am leaving this up to you. Try the other test. You can use many other tests which we have discussed earlier to check whether it is converging or diverging. Right now, by the divergence test, we cannot comment upon this. Simply as that. Let us see this one. It is saying use the nth term, whether it is written nth term or the divergence, both of them are the same. So here the general term is sine of 2n. So let's calculate limit n tends to infinity, sine of 2n over here. Now if the n is going toward infinity, you know the graph of sine is like this. It goes like this. This is plus 1, this is minus 1. And as we are going towards infinity, as the input value over here is going toward infinity, the values of sine are oscillating between minus 1 and plus 1, up, down, up, down, up, down. So we can say it is oscillating between minus 1 and plus 1. So it is not coming out to be a particular answer. So here we will say the limit does not exist. Limit does not exist means we cannot say where it is approaching. It is fluctuating between minus 1 and plus 1, but exactly where it is approaching, we cannot say. So the limit does not exist, but it is not equal to 0, right? So therefore again we will say the series diverges. It is not equal to 0. It is somewhere between minus 1 and plus 1. So we say limit does not exist, but according to the divergence test, we will say diverges because it is not 0. Let's take the next example. Here also the term is there. So we will simply say limit n tends to infinity 2 plus 3 over n. Now when the n is going toward infinity, 3 upon a very large number, this will go towards 0. So answer will be 2. And now we know 2 also not equal to 0. So therefore it diverges. Very easy. Let's take one more example. N cube plus 1 upon n square. So we'll apply limit n tends to infinity n cube plus 1 upon n square. In this case it is polynomial upon polynomial, and degree of the numerator is more than the degree of denominator. So we have discussed 3 cases. When the degree is same, so ratio of leading coefficient is the answer. When degree of numerator is less than the degree of denominator, just like we have discussed in the previous question, the answer is 0. But if the degree of numerator is more than the degree of denominator, the answer is infinity. So we are getting infinity again, which is not equal to 0. So again we say this diverges. So I hope you have understood these 5 questions and how we are using the divergence test to check the divergence.